vast majority of students never get a grip of this chapter named moles in chemistry, because they spend about 2 years in GCSE, 2 years in A levels, trying to grapple and just avoiding suffering through this chapter without realizing how key and important it is for their educational and academic growth. I need to demystify it. Tried in the past, didn't work. Moles are the same, regardless of level. You can simplify the equation. You can infantilize the formulae, but the basic concept remains ever so same concretized. Moles have these following sections. So they analyze quantitative reaction changes in solid, liquid equations, gas equations. They also take into account electrochemical reactions, reverse and complex titrations, and then thermochemistry interactions, enthalpy, and Born-Haber and Fritz-Haber. Born-Haber, Fritz-Haber, like ammonia production, sulfuric acid production, vanadium catalyzed. And also a large part of moles deals with organic chemistry, empirical formulae, research questions, where you have to find out the empirical formulae of the organic molecule. So the concept is the same, but the students are getting bogged down, intimidated by the length of question. Don't get bogged down. Break the question into different parts, smaller parts. Pick the information and apply the formula. That's pretty much it. It's not GAMSAT. It's not MCAT, where you'd be tested in unseen ways on the knowledge. It's not abstract application of knowledge. It's actual, real, direct extraction of the knowledge. And the formulae in most cases are always given, apart from a couple of formulae in electrochemical electrochemistry, the Z, E equals Z, the valency. Apart from one or two formulae, every other formulae is given on the sheet, the exam sheet at the back of your exam question paper. So with the Born-Haber cycle, you have one of that, and then you have the another cycle, which is Hess's law. Hess's law comes under enthalpy calculations, enthalpy of heat, enthalpy of molar dissociation, enthalpy of neutralization, enthalpy of hydration, enthalpy of, it's basically calculating 1 mole of chemical element undergoing 1 mole of change. And then you have a little bit more, slightly more complex, I'd say, which includes it consists of first order, second order decay rate equations, which is reaction kinetics. It contains log equations, log calculations, minus log H, minus log OH, and then Ka calculations, then P minus log Ka calculations. So this is what, and then at the end, which I forgot to write down, is radioactivity and solubility chapter. I'm getting sick of a lot of pupils coming to me during recess, crying about moles and how intimidated they are. They're feeling horrible. They hate themselves because they can't do these calculations, and they have higher aspirations of getting an A grade, A star in A levels. So, I've spoken to many of you, but please use this video, save it for future use, and please don't be intimidated. It has chapters. So let me demystify it. This chapter is about practicing valencies, understanding the importance of valencies. Okay, how to mismatch valencies. This is how to calculate the relative atomic masses of the elements and the compounds, and then the relative molecular masses of larger conjugates like sodium, potassium tartrate, tetrahydrate, magnesium sulfate, heptahydrate. And then we move on to solid equations like burning, thermal decomposition equations, solid on solid equation, solid on liquid equation, liquid and liquid equation, double salt displacement equations. And then we have empirical formula. In this chapter, most people get confused when they are faced with an organic chemistry question instead of a physical chemistry question. Their brain stops working. Their neurons can't fire anymore because, of the CXH2X plus Y is a Y and an O, formula. It just traps them in their mind. It's the same thing. You have to follow the sequence, and you'll find the organic formula without effort. And then in the gases, you have STP. So in gases, please remember you have two kinds of calculations. One is standard temperature pressure, and then the room temperature pressure. Room temperature pressure is 24 decimeters cubed per mole, and then standard temperature pressure is 22.4 decimeters cubed per mole. Okay, just remember that. Um, Life is about memorizing. You have to memorize it. No matter how much demonization, memorization experiences, you have to learn to memorize things in your life. Okay. Uh, so that's it. That's that. And then we have chapters like solutions, complex titrations, reverse titrations. We have complex, concentration calculations. A equals E epsilon CL. C1 V1 equals C2 V2 C1 V1 over N1 equals C1 C2 V2 over N2. Then we have indicator calculations. HI equals H plus I. And then we come to the thermochemistry, which talks about Hess's law, enthalpy calculations, as well as free Gibbs energy calculations, which are very, very simple. Just do a few questions with honest sincerity, and you'll get the hang of it. Then we have Born-Haber calculations, Fritz-Haber ammonia, sulfuric acid, catalytic industrial process calculations. So in the gas chapter, we not only do the SDP and RTP calculations, we also deal with partial pressure and dissociation constants, and we also talk about equilibria, like how much of the molecules would move over to ammonia if the pressure, the temperature, concentration are changed. Okay. So this is part of reaction kinetics and a bit of thermochemistry liaising with the gas side of moles. Then this in the very interesting chapter of solubility. It's just remember that higher the temperature, higher the solubility. When you reduce the temperature back, the solid which dissolved at additionally incremental temperatures will recrystallize. That's all it is. But you're not required to implement it. Sometimes they're just asking you about the graph that look at 20 degrees, 10 grams dissolved in 2 liters. So look at the graph and tell me how much would dissolve at 50 degrees. You don't, but you can mention when the temperature drops back to 20, the differential would recrystallize. Just mention that to save your self from pernicious examiners who want to mark you down. And then we have radioactivity, and then electrochemicals. So radioactivity, counts per minute, counts per second. That's it. That's all it is. And dissociation constants. And then electrolysis is calculating amount deposited on anode or cathode, moles of gas released on anode or cathode, amount of cathode dissolved or amount of anode dissolved, Q equal IT, and all of the typical physics A-level formulae used here in this chapter. That's pretty much it. That's it. The daunting part is when you come across organic chemistry equations, empirical formulae, organic chemistry equations, partial pressure equations, this and that. And that's a bit vague, but I'll clarify. It's my job to clarify it. Just bear with me, please. Bear with me and I'll sort it out for you as we progress through the semester. Thank you. Cheers.